Alright, here we have a runner jogging on a completely circular track. They don't probably exist very much, but let's just say they do, with a radius of 60 meters. And according to this, he or she is able to do one lap in 47 seconds. So the time is 47 seconds. And we need to find the force of friction needed to do this. So remember, if someone's going in a circle, their centripetal force is towards the center of the circle. So friction is actually pushing them towards the center of the circle. And we want to find out this force of friction, what it is. So since we're assuming it's the only force pushing them towards the center of the circle, we know that the force of friction is equal to the centripetal force. And we know the formula for centripetal force is a person's mass times their velocity squared over r. Remember, it's from this portion, which is the acceleration of somebody in a circle, times their mass, which is another version of F equals ma. So we're just replacing a with v squared over r. Anyway, so what do we know? Well, we know the person's mass. Their mass is 65 kilograms, so that's fine. We know the radius is 60 meters. The one thing we are lacking is we do not know the velocity at this moment. So in order to find the centripetal force, we need mv and r. So we have to find v. It's not given to us. We got to calculate it. And so we're given the idea that one lap is completed in 47 seconds. So again, it's basically a distance versus time. They complete one lap in 40 seconds. That's time. This is distance. But laps per second isn't really a unit that's going to help us. We need meters per second. So what is the distance of one lap? So it's a circle. And again, the circumference of a circle is 2 pi r. So 2 pi times the radius, 60, will tell me the circumference of this circle. So 2 pi times 60, and I get 377 meters. So that's my radius. So the person will go 377 meters over 47 seconds. And so if I do 377 over 47, I get the speed is 8.02 meters per second. And I'm not going to round that yet, not until the end of the problem. So I'm going to leave it as is. So I know the mass, I know the radius, and I know the velocity. Now I can calculate the centripetal force. So I've got 65 kilograms times 8.02 meters per second squared, I ran out of room there, over 60. And that is going to be my centripetal force, which is equal to my force of friction, which in this case, 65 times 8.02 squared divided by 60, I get about 69.7 newtons. And based on the sig figs given here, I might just call that 70 with a decimal point newtons. So that is the force of friction needed in this situation. So again, I identified the force of friction was going to be a centripetal force because the person's going in a circle. There were no other forces acting in or out of the circle, so I knew that these forces are equal, and then I knew the formula for centripetal force. And it was just a matter of identifying the variables and plugging them in. So until next time, I am Derek Genova. Have a delightful day.